Hi everybody, this will be fun. I'm going to work out with this circle. I guess it's circle X. Yeah, it tells me that over here, doesn't it? Circle X with TG, tangent to the circle, and AE and TC are diameters. I'm going to figure out a bunch of arcs and some angles, about 8 angles and a couple of arcs too, and it'll be fun. Things I tell you ahead of time that I know I'm going to look for. When you have a diameter, and here I have a couple of diameters, a diameter TC gives me a semicircle, so I know that that arc's going to add up to 180. The other arc would as well. We have another diameter, that was AE, and so I'm going to get 180 degrees here and 180 degrees there. And the first thing you want to do is figure out all those arcs. So I'll label what's given. DE being 50, CD being 20 degrees, FE is also 50. Let me see where that's going to go. Right here is also 50. And then arc AB is 54. And that's enough information for me to figure out the other arcs first. I'm sure that's what I want to do. Let's jump right in. I know I expect 180 degrees here. Since we have a diameter, I think I'll get a ruler on that. Since we have a diameter here, I know this must be 180, and I have 120 showing, 50, 50, and 20. So that would leave 60 degrees here, wouldn't it? 120 and 60 more. So I know about arc TF, which is asked, would have been 60 degrees. And I'm going to need to know about arc AT. And here's a thought. Did we know the measure of angle 1? I think it's going to be important to us in a minute. Angle 1 is is a central angle, and it's the same as the arc it cuts, and it cuts an arc of 70 degrees. And its vertical angle partner would also have to be 70 degrees. So I'm thinking that the arc that it cuts must be 70 degrees. Yeah, these must be congruent arcs because they have congruent central angles. So I think arc AT must be 70. And if I expect to get 180 out of this semicircle, semicircle TBC, and here I see 134 showing. Oh, that's 124 showing, didn't it? Yeah, that's 124. So if we take that out of 180, I got 180. Take out 124, don't want to screw that up. I think that's going to be 56 degrees, huh? Making this thing be 56 degrees. Adding those up later, yeah, that's 110 and 70, there's 180. Now I know all those arcs. I know about arc AT, which was 70, which gave me the power to figure out the other arcs. Now I'm going to go jumping through here, start finding the measures of some angles. Angle 1, a central angle. How do you measure a central angle? Same as the arc it cuts. Angle 1 cuts an arc of 70 degrees. Looking for angle 2. Hey, what kind of angle is that? That's an inscribed angle. An angle with its vertex on the circle. An inscribed angle is 1/2 of the arc it cuts. This angle cuts arc BC 56 degrees, and being half of the arc it cuts forces that to be 28 degrees. Then looking for angle 3. Here we have it now. That's an interesting place, angle 3. To get angle 3, it's not a central angle, and it's not an inscribed angle. I'm going to look at the two arcs that it cuts, add them up and divide by 2. It's the average of the arcs it cuts. You should look at the vertical angle partner as well. Angle 3 cuts an arc of 54 degrees, plus, and if I bring it out the other direction, it also cuts arc TE, which is 110 degrees. So 54 plus 110 divided by 2. An angle just somewhere inside the circle, you add the arcs and divide by 2. So that would give me 164 divided by 2, and that's 82 degrees, isn't it? 164 divided by 2. Then we're talking about 82 degrees for angle 3. What about angle 4? Angle 4 is outside the circle, formed by 2 secants. And things to just wanting you to remember these ideas. When you have an angle just somewhere inside the circle, you add the arcs it cuts and divide by 2. That's if an angle's inside the circle. But if an angle's outside the circle, that's a different approach. You subtract the arcs that it cuts and divide by 2. Look at angle 4 carefully. It cuts an arc of 60 degrees, arc TF, and it cuts an arc of 20 degrees. If I seek the measure of angle 4, it would be the bigger arc 60 minus the smaller arc 20 divided by 2. Therefore, 40 divided by 2, I'm looking at 20 degrees for angle 4. Not because that arc was 20, but because when I subtracted and divided by 2, I got 20. What about angle 5? Where do we find angle 5 anyway? Oh, I see it now. Angle 5 just somewhere inside the circle. I have to add those arcs and divide by 2. It cuts an arc of 50 degrees plus, and then bring the rays out. The other arc that it cuts is AD, which is 110 and 20 more. That's 130. So 50 plus 130 divided by 2. That looks like 180 divided by 2, doesn't it? So that forces that angle 5, to be 90 degrees. I'm okay with that. It looks like it's about 90 degrees to me. That just seemed like a square corner there. So it looks as it should. Looking for angle 6 now. Now this is an interesting place. How are we going to get this angle here? I don't know a way to get that angle, but I do know a way to get that angle. This is an exterior angle on this triangle. I cannot measure this angle by knowing about arcs. Let me go ahead and figure out about angle 8. And then I think I can come back and figure out about this angle 6. Angle 8, can you talk about angle 8? It is inscribed in a semicircle, isn't it? Cuts an arc of 180 degrees, angle 8 does. Yeah, angle 8's got to be a right angle. It's got to be 90 degrees. And if this one's 90, and angle 2 we knew was 28, but I think I can find this angle. I can do that lots of ways. These two angles add up to 118. Subtract that from 180. I think this ought to be 62. But we could tell you what we could also do to get this angle. Look at the arc that it cuts. It cuts an arc of 124, 70 and 54. Divide that by 2, and yeah, we ought to have this angle be at 62 degrees right there, huh? It's good the angles of this triangle add up to 180, and now can I get angle 6? Yeah, it's the supplement of that 62 degree angle. That would have to have been 118, wouldn't it? Now, that's an interesting thing. I don't have a way to measure that angle by looking at the arcs. How about angle 7? See what we can do about that as well. Angle 7, formed by a tangent and a chord. What I would like you to remember is whenever an angle has its vertex on the circle, it is 1/2 of the arc it cuts, like an inscribed angle. So the question becomes, what arc does angle 7 cut? With a tangent and the chord, it cuts arc TB, which is 124 degrees, 70 and 54, 124, and because it's not an inscribed, because its vertex is on the circle, it is 1/2 of the arc it cuts, and that would have to be the 62 degrees. I'm sure there's other angles we can find out about, but those all make sense to me. And I got one I'd like this for you to work through. Pay attention to the details and appreciate your time.